The interaction of the solar wind with the Earth's magnetic field is a complex phenomenon which has interested the scientific community for a long time. The cluster mission is designed to study this interaction in unprecedented detail. 4 spacecraft are launched, maneuvered into various intermediate orbits, and finally brought together to fly in formation in a carefully controlled tetrahedron constellation. Lifting off from Baikonur, a Russian Soyuz rocket launches the first pair of the cluster spacecraft into space. On the ground, specialists in ESOC's main control room and flight dynamics room stand by to take charge of the 2 spacecraft immediately after their separation from Fregat, the rocket's upper stage.
All positions OD, my loop. The liftoff time was just confirmed from Baikonur. It was 12 hours, 47 minutes, 0 seconds, which was exactly the end of the launch window. Flight dynamics, did the information come too late for your time in it?
That's negative, but we will proceed immediately now.
With the first burn of Fregat's motor, a circular orbit is achieved. Following a second burn to reach an elliptical orbit, an attitude slew maneuver precedes the spin-up to 5 revolutions per minute. The 2 spacecraft then separate one by one from the Fregat.
We've just received confirmation of successful separation of 2 cluster spacecraft from the Fregat upper stage.
We'd better get something about the achieved spin rate. Could you please find out?
Yes, I will. OD, this is Flight Dynamics on your loop.
Flight Dynamics OD, go ahead.
Would you please remind and alert the staff at the Kiruna station to immediately report on the antenna gain variations once we have AOS?
I will, Co. They have their procedures anyway. But I agree it's very important to know as early as possible.
We've just been called from Kiruna. They confirm a nominal spin rate. Did you copy Flight Dynamics?
Copy.
The 2 burns of the Fregat upper stage were at the right time and with the right attitude. Otherwise, the spacecraft, together with Fregat, could have burned up into the atmosphere. And we in ESOC couldn't do anything about it. There are just 2 cases conceivable for which Flight Dynamics could help in saving the spacecraft. One case is a failure of the second burn of Fregat. The other case is related to the separation conditions. If, instead of spinning at 5 RPMs, the spacecraft were tumbling, we at ESOC could still fully recover the mission.
Seems like we have already removed the large notation. Admon, do you have a real-time estimate of the spin rate?
Yeah, we are already at 11.5 RPM.
OD sum on Flight Dynamics loop.
Flight Dynamics OD, go ahead.
Go Flight Dynamics.
This is to report on the progress of this spin-up. We are already at 11.5 RPM.
Copy, and congratulations to all team members. We made it.
Initially, a sequence of 4 apogee-raising maneuvers at perigee will bring the 2 spacecraft into highly eccentric orbits, at times flying extremely near to each other.
The risk of collision of the 2 cluster spacecraft, although extremely small, must be addressed at all steps of the operations. We have to make sure that within the limits of accuracy achievable, the risk of collision remains within acceptable limits. Obviously, after a collision, no recovery is possible. Luckily enough, there are mishaps where we can recover the mission. Take, for instance, the case of a failure of the main engine of one of the spacecraft. Here, instead of making 4 large apogee-raising maneuvers with a large thruster, we would need to make many, many small maneuvers with smaller thrusters.
Flight Dynamics OD on my loop.
OD, go ahead.
Since all attempts have failed to start the main engine on spacecraft 3, we got to define an alternate mission sequence using the small thrusters. Do you have a rough idea how long it will take us to reach the apogee target height?
We have prepared a prediction assuming a reasonable gravity loss. It will last several weeks to achieve the target orbit.
After the 4 apogee raisings, another maneuver is required to change the inclination of the orbit. That maneuver, performed way out at apogee, requires the utmost attention. First, the spin axis has to be turned with high precision into the optimal firing direction. And second, the time and duration of the thruster firings need to be selected very carefully. Detection of a possible misperformance via orbit determination will not be possible right away. That means, for instance, that the risk of a possible re-entry into the Earth's atmosphere might only be known very late.
Break, break! We have a declared emergency on both spacecraft. Please gather quickly at the board here. So that's the situation. This is where we should be, and this is where we are. What do we need? We need 2 stations at least, because we have 2 spacecraft, so that we can handle everything in parallel. Orbit determination.
Apart from some initial gaps which we have in the coverage, we have afterwards 2-station coverage from Perth and Canberra.
What about the attitude? Is it all right?
We have good attitude for both spacecraft because we have good sensor measurements.
What about orbit optimization?
We need a maneuver of about 80 meters per second. And before this maneuver, we have to slew the spacecraft by about 50 degrees.
How long does it take for command generation to prepare the telecommand?
It will be about 10 minutes per spacecraft plus some checking time.
QC, and you? Everything ready?
Ready, yes.
You're always ready? Very good, fine.
Instead, following the nominal operations plan, the 2 spacecraft will by now be flying near to each other in an orbit with a safe perigee height of 16,000 kilometers. The orbit will be polar, thus being inclined by some 30 degrees to the previous orbits, and it will be quite close to the final operational orbit, reaching out as far as 125,000 kilometers, optimal for the science to come.
Spacecraft 2 and 3 have reached their operational orbits. We're there.
Having achieved a successful orbit injection for the first 2 spacecraft, what follows can be considered a repeat. 4 weeks later, the second pair of spacecraft will be launched by another Soyuz Fregat rocket. The challenge will be enormous. The sequence of maneuvers for the second pair of spacecraft needs to be optimized in such a way that a rendezvous is possible with the first pair of spacecraft, achieving the required tetrahedron constellation with high precision.
Now the final orbit is reached for all 4 spacecraft. Cusp, bow shock and plasma tail await to be investigated. Traveling and measuring in space, our spacecraft formation paves the way for new scientific discoveries.